So this video is on 10-61 to 64. So this image right here is the Earth. And there is a meter stick that is sticking up. Okay, and we see that right here in this picture, but that's this right here. This is the meter stick sticking up. It's casting a shadow. And we're going to use this information to help us answer these questions. So some of the information that they give us, we know that Alexandria is 500 miles to Cyan. So right here, this is 500 miles. I'm going to put on the bigger picture here in a second. We also know that the shadow cast by the meter stick is 127 millimeters. So this shadow right here is 127 millimeters. Okay, and that's right here. That's that little piece right there. We also know that a meter stick, okay, is 1,000 millimeters. So this right here is 1,000 millimeters. Okay, so this right here is 1,000. So let me put this information on this. Okay, so we know that this right here, let me just make it a little thicker. So we know this right here is 500 miles. Okay, so that's going to be 500 miles. We know that this is 1,000 millimeters. Okay, this over here is miles. We know that the shadow that it's casting is 127, and that is millimeters. What we want to find first, okay, the first question that they're asking us here is determine the angle of theta that the sun's rays make with the meter stick. That's the first thing we want to find. So that is this right here. This is what we want to find. So what we see is when we're doing this, this is opposite and this is adjacent. So I'm going to use tangent. So I'm going to be working out tangent theta is equal to opposite, which is 127, over adjacent, which is 1,000. Now I want the angle theta, so I'm going to have to do tan inverse of 127 over 1,000. And I'll put that into my calculator. Let me get Desmos up. Okay, so when I'm doing that on Desmos, I do want to come and change it to degrees under the wrench. Okay, so under this wrench right here, I want to change it to degrees. Then I'm going to do tan inverse of 127 divided by 1,000. And when I put that into my calculator, I get 7.2378. Okay, so let me just jot that down. So this is going to be 7.23, let's say 238. 7.238 degrees. Okay, so that's the first question they want. So for A, the answer is 7.238 degrees. Then it says, assuming that the sun's rays are essentially parallel, determine the central angle of the circle if the angle passes through Alexandria and Cyan. How did you calculate your answer? So we want to find this angle right here. Now, to find that angle, what I'm going to do I am going to have these parallel lines. So that, and I'm also going to think about this one here. Okay, that's the sun rays. And it is being cut by this transversal. And when that happens, we have alternate interior angles are going to be congruent. So this angle is going to be the same as this angle. So I know that this central angle is going to be 7.238 degrees also, because parallel lines cut by a transversal. Okay, so 7.238 degrees. And why? Because of alternate interior angles are congruent when we have parallel lines cut by a transversal. Then the next question that they want us to answer, they want us to figure out what so the circumference of the Earth is, if we know that this here is 500 miles. So what we're going to do to figure out the circumference, I know that circumference is equal to 2 pi r. And I know that 2 pi, well, and I know that that 500 is part of the circumference. It's not the whole circumference. I have 7.238 degrees out of 360 degrees of the circumference that is equal to 500. So what I'm going to do is I want to get this, which is my circumference, by itself. So I am going to multiply both sides by the reciprocal, 360 over 7.238. So this side also, 360 over 7.238. So let me do that math. So I'm going to be doing 500 times 360 over 7.238. And I get 24,868.7. So let me jot that down. So what ended up happening here is this and this canceled. This and this canceled. That's why I multiplied by the reciprocal. I was left with 2 pi r, which is our circumference. And on the other side, that's what I put into the calculator. And that gave me 24,868.75. And that is our circumference. So I'm just going to copy this little piece right here. And that is our circumference. Then on D, it says use that result to approximate the radius. So if I know that this is our circumference, and circumference is equal to 2 pi r, I basically want to get the r by itself. So what I'm going to do is I'm going to divide by 2 pi by 2 pi, and that's going to give me the radius, and this is going to be the radius of the Earth. So let me take 24868.75, and I'm going to divide it by 2 And let me get pi here. And that's 3,957.98. So let me jot that down. So 3,957.98 miles. And that is our radius. And let me just copy this. Okay. Now, the next thing that they want us to look at in 62 is they're talking about kind of understanding some vocab here. When we are talking about a central angle, this angle right here, that 40 degrees there, that is considered a central angle. And when this central angle is 40 degrees, the arc that it forms has an arc measure. We call that an arc measure. That is going to be the same as our central angle. So when they're asking us down here, what is the arc measure? Okay, what is the arc measure of SU? It is going to be 40 degrees. It's an angle. It's not an arc length like we were talking about when we're talking about the 500 over here. Okay, this was an arc length. When I'm talking about it in terms of degrees, that's an arc measure. Then they ask us, what is the measure of arc SZU? That's that bigger one. So the measure of arc SZU is going to be the rest of the 360. So that's going to be 320 degrees. So this arc measure is going to be 320 degrees. Now, the next thing they wanted was when we are talking about trying to find the arc length, okay, not arc measure, what we are going to do is if we're trying to find it for this particular problem, okay, so this same problem where we have 40 degrees as our central angle and 40 degrees as our arc measure, they're saying here that our radius is going to be 12. So this radius right here, from here to here, is going to be 12, okay? And we want to figure out what the arc length is. So the arc measure was 40 degrees. What is that arc length? So I'm going to take the part that I have, 40 out of 360, times it by circumference, and circumference is 2 pi r. So it's going to be 2 pi times 12. So that's really going to be 24 pi. And I'm just going to put this into Desmos. Okay. I'm going to take 40 over 360, which actually is 1/9, and I'm going to times it with 24. And when I do, I get 2.6 repeating, but if I hit this right here, it's 8 over 3. So I could think of this as 8 over 3 pi. So 8 pi thirds. Now, if I wanted that as a decimal, okay, I can take this and I can times it by pi, and then I get about an 8.38, which is about an 8.38. And this is going to be in inches. So the arc measure is 40 degrees, but the arc length is that 8.38. Okay. Now, on 63, they're talking about inscribed angles. An inscribed angle, just like any inscribed shape, is going to have all of its vertices touching on the circle. Okay, so each of these vertices, okay, are touching on the circle. That is an inscribed angle. Where this one here that I'm doing in purple, that is called a central angle. So the purple one is called a central angle. And the blue one, as they have labeled there, is an inscribed angle. And then the arc that is formed, that is called the intercepted arc here. Whoops, that's what they call it, intercepted arc. That's the one formed by the angle. Now, they want us to kind of look at the relationship between these on the next page. So on problem A of 1063, I color coded these. So I have this angle F here. Now, what they wanted you to do is to trace angle F on your patty paper and then compare it to these angles here. Okay, trace angle G, compare it to these angles here. And same with H. Now, what you were to discover is that all three of these angles, this purple one is forming this arc JK. This orange one is forming this arc JK. This red one is also forming the same arc JK. And so it doesn't matter where the vertex of this inscribed angle is, if the endpoints are forming the same arc, the angles are going to be the same. So a visual of that, if I look at this picture here, okay, I have A and C, okay, here, let me adjust it. Okay, let's say it's 50 degrees, okay. This inscribed angle is 50 degrees, but it doesn't matter where I move it to. It's going to stay 50 degrees as long as the A and the C do not change. The endpoints don't change. If I change the endpoint, okay, either of the endpoints, then that's going to affect this inscribed angle. But once these endpoints are set, it doesn't matter where this vertex will be. If it forms this angle, this arc, it's going to always be the same. Now, the next bit of information that they wanted us to find is the following. Now, I have this red inscribed angle X that is forming this arc right here. It is forming this arc. Here, let me do it with this. It is forming this arc, WY. And we have this purple central angle that's also forming this orange arc, WY. They wanted us to, again, use the patty paper and compare them. What you were to find was that this angle here is smaller than this purple one. So the inscribed angle that forms the same arc as a central angle is smaller. And what you'll notice is it actually is two of these inscribed angles that makes up one of these central angles. So again, visual. If I am looking at this picture, let's say I make my inscribed angle be 100 degrees. Okay, so here my inscribed angle, sorry, not my inscribed angle. My central angle is 100 degrees. It forms this arc AC. This inscribed angle B also forms this arc AC, and notice that it's half as much. If I make this, let's say 122, then the inscribed angle, no matter where I move it, as long as it's forming the same arc as the central angle, is going to be half as much every single time. So that's what they wanted us to understand. So then we're going to use that information to answer these questions down here. Okay. So on the first one, okay, I have this inscribed angle here, X, and that inscribed angle is forming this arc, and the arc measure of that is 118 degrees. So the inscribed angle that makes that arc is going to be half of that. So half of 118 degrees is 59 degrees. Now this one's going the other direction. I know this inscribed angle here has a value of has an angle measure of 41 degrees. So this arc that it's forming, is going to be twice that. So this is going to be 82 degrees for its arc measure. Now on C, they want us to find a few different things. So the first thing I'm going to do is I'm going to be looking at this angle Y here. So this Y is formed by that inscribed angle. That inscribed angle here is 78 degrees. So if the inscribed angle is 78 degrees, the arc that it forms is going to be twice as much, which is going to be 156 degrees. Now, if that is 78 degrees, and this is 90 degrees, and this is an inscribed angle that is 90 degrees, and that is forming this arc here. This arc, which is X, is going to be double 90 degrees, which is going to be 180 degrees. Now at this point, I could actually take 360 minus 180, which is 180, minus 156, and end up getting my Z. So when I do that math, I end up getting 24 degrees. But I can also get that same thing because if I know that this is 78 degrees, I know that this is 90 degrees. In a triangle, this is going to be rest of the 180, which is 12. So when I have this inscribed angle that's 12 degrees forming this arc, the arc is going to be double, which is going to be 24 degrees. On D, my central angle that forms X is 56 degrees. So that means that this X has an arc measure of 56 degrees. This inscribed angle that also forms that same arc measure, same intercepted arc, is going to be half of that. And so half of 56 is 28. Now, on E, if this angle here is angle X and it's forming this arc, which is 114 degrees, then this central angle is going to be the same value, 114 degrees. Now, this angle here, y, which consists of this whole thing here. Okay, let me get rid of that. Okay, this whole thing here, which forms the same arc that the other one formed. So if that arc measures 114 and that y is an inscribed angle, is going to be half of that 114. And half of 114 is 57 degrees. On F, this inscribed angle, which is 28, forms X, which means X, the angle, the arc measure, is going to be double that, which is going to be 56 degrees. This Y forms that same arc. The endpoints are at the same spot. So it is going to also be 28 degrees. And hopefully that helps you out.